Geometry of the covalent molecules in which the central atom is having both bond pair and lone pairs. Actually, we will see that how the lone pairs are distorting the geometry of a covalent molecule. We made the table as bond pair, lone pair. Including bond pair and lone pair, we will get the total number of electron pairs. Accordingly, we will get the hybridization of central atom, the expected geometry. As we know, if it is sp, it would be linear and so on. Next, we will see how that electron pairs are being oriented. That is how the bond pairs and lone pairs are being oriented. And what is the actual shape of the molecule. Let's start with that. First, we will see. Now, I'll tell you one point, that if it is having a single bond pair only, as because like this, as suppose this HCl, it is always along a line and it is linear, right? So howsoever be the number of lone pairs present, it is always linear. Therefore, we will start with at least 2 bond pairs, and let's see 2 bond pair and 1 lone pair, how the shape comes. The total number of electron pairs is 3. Based on this total number of electron pair 3, it is actually AB3 type, or it is AB2 and 1 is for electron. E is for electron, AB2 E type. Since the total number of electron pairs are 3, it will be sp2 hybridized. So expected geometry is planar, trigonal, and the actual orientation of electron pairs are, we know that it forms 120-degree bond angle. So keeping this 120, but 1 is the lone pair. It is not contributing in the shape. Therefore, ultimately we will get AB like this, AB2, and this is just the inverted V, or having a V-shaped structure, actual shape. The second one, we will have 3 bond pair and 1 lone pair. Total number of electron pairs is 4. So it comes AB3 E type. sp3 hybridization. Expected shape is tetrahedral. And the orientation would be just like this. This is our methane molecule, and if we just remove this, so this is ammonia, lone pair and 3 bond pairs. This is called a trigonal pyramid shape. The base is a triangle, this is also a triangle, this is also a triangle, this is also a triangle. So it is trigonal pyramid shape. Next, we have 2 bond pair, 2 lone pair. This is also 4. This will be AB2 E2. Total number is 4. Therefore, this is also sp2 hybridization. The expected shape is again tetrahedral. See, this was methane and I made it ammonia. Now, if this is also the lone pair, how the shape looks like. This is A. We have the lone pairs. And we have to do nothing with the lone pairs. Therefore, the shape is again V-shaped, or also called bent. That's how the water molecule looks like. And now you could be able to see why water is having a permanent dipole while carbon dioxide, which is sp hybridized, is linear, not having a permanent dipole, but water being polar or this bent shape is having a permanent dipole. Now we'll have 4 bond pair and 1 lone pair. So then it would be 5 AB4 E type. 5 means it is sp3d. Expected shape is trigonal bipyramid. In trigonal bipyramid, how the shape would be? This is A. We have this is the plane of the triangle. One is above the plane, another is below the plane. So this actually looks like a seesaw. You might have played this seesaw. 3 bond pair, 2 lone pair. This is also 5. AB3 E2. This is also sp3d hybridized, and this is as expected shape is again trigonal bipyramid. The arrangement of particles are, we have now 3 bond pairs. So how that 3 bond pairs are present and the lone pairs are present as the 2 lone pairs in one plane. Now there could be more possibilities to have the lone pairs, but I'm taking only the most stable configuration. So how it looks like? A, this is T-shaped. See, this is T-shaped. The next is 2 bond pair, 3 lone pair. This is also 5, and this will be AB2 E3. This is also sp3 dehybridization. Expected shape is trigonal bipyramid, and the orientations are the most stable orientation is all the lone pairs are staring at the plane. Energetically most stable configuration is being taken, and the bond pairs are furthest apart. So it is simply a linear or 180-degree shape. Having the same, we could have 5 bond pair, 1 lone pair. The total is 6, known as AB5E. Hybridization is sp3d2 due to this total 6. Expected shape is octahedral, and the practical arrangement is this is the square, one is below the plane and One is above the plane, one will be occupied by the lone pair. So it is the square pyramid actual shape. 4 bond pair, 2 lone pair. This is also 6, AB4, E2. This is also sp3, D2 hybridization. This is also octahedral, and the shape would be all the bonds will be in one plane, and the lone pairs are above and below the plane. So the shape is actually square planar. So we got how actually we are writing the number of bond pairs, lone pairs, and accordingly what is the actual shape. In case of hybridization, total electron pairs to be calculated, and then we have to see how that lone pairs are distorting the geometry of the molecule by the orientation, and we are taking the most stable energy orientation